Cool. So what the class has been telling me is that we really need a little refresher on fractions. Fractions, right? So anytime we are writing a fraction, we are writing it as a part over the whole. Okay? We're writing it as a part over the whole. So if I were to say 2/3, what I'm saying is if I were to have a circle that was cut up into thirds, 2 of those thirds would be represented. All right? These are going to be the same thing. Now, the issue is when we have to add and subtract or multiply or divide fractions. Okay? When we add or subtract fractions, say I had 2/3 plus 1/4. To be able to do this effectively, I need to have something that we call a common denominator. Common denominator. In this case, when I'm looking at 3 and 4, I see that finding a common denominator is a little bit difficult. They don't go perfectly into each other. But if I were to multiply 2/3 by a special version of 1, in this case 4/4, and if I were to multiply 1/4 by a special version of 1, in this case 3/3, I would have my common denominator. Why? Because this is how multiplying and dividing fractions work. When I multiply straight across, numerator times numerator. So 4 times 2, and that's going to be over 4 times 3. Likewise, for my other one, I multiply straight across. So I have 1 times 3, and that's going to be all over 4 times 3. When I simplify this, 4 times 2 is 8. 4 times 3 is 12. I'm going to add that to my blue one. I'm going to simplify it. 1 times 3 is 3. 4 times 3 is 12. I can now add these together because they have a common denominator. I have twelfths. Now that I have common twelfths, I just add my numerator together. So I get 8 plus 3 all over 12. It becomes 11 twelfths. That is my answer to this question here. Okay? That's how we add them. We have to find a common denominator. We do that by multiplying it by a special form of 1 to cause our denominators to be equal to each other. All right? The easiest way to get these numbers is, you see I took 3, I multiplied it by 4 because 4 was over here. I took 4 and I multiplied it by 3 because 3 was over here. That's how I chose how to do it. All right? So if I had 1/6 and I was adding like 7/13, what I'm going to do here is I see that since this is 13, I'm going to multiply this one by 13/13. Multiply that there. And since this is 6, I'm going to multiply this by 6/6. I am choosing that 6 because it's the denominator of the other term. I am choosing that 13 because it's the denominator of the other term. Gracie? It does not have to be the same number. The only thing that's important is that you're multiplying this by 1. You see how orange is 1? 13/13 is 1. You see how blue is 1? 6/6 is 1. We're always multiplying and dividing by 1. We're free to do that however we want. But in this case, it matters. We get 13, and then 13 times 6, which is not something that I have in my head. So 13 times 6 is 78. Okay? And then plus, and then what is that? 42 78ths. And so all of that's going to equal 55 78ths. That's going to be my answer. I don't know if this one can simplify. 55 reduces by 5 and 11, and neither of those numbers go into 78. So I think that's as simplified as it gets. Okay? Now, there's a special thing when we multiply and divide fractions, right? If I had 2/3 and I was multiplying it by 7/4, right? I multiply straight across. I do 2 times 7 all over 3 times 4, which becomes 14 over 12. I can then reduce this fraction down. I see that 2 goes into 14 and 2 goes into 12. 2 goes into 14 7 times, 2 goes into 12 6 times. That's my reduced fraction. Now, I can do that, but if I'm smart, if I'm sharp, I can see that I can reduce it right here. I see that 2 divided by 4, well, 2 goes into 2 once, 2 goes into 4 twice. So now I just multiply across. I have 1 times 7 over 3 times 2, so I have 7 over 6. I end up with the exact same thing as I had up here. But what I saw here is that I saw that 2 and 4 could reduce down. Yeah? Now, when we're multiplying or dividing, we do not need a common denominator. We don't need a common denominator at all. That's only when we're adding or subtracting that we need a common denominator.
So when you're adding and subtracting, you don't have a common denominator?
You need a common denominator to be able to add and subtract. Right?
Can you find the common denominator the same way that you simplified it? So I can go to the denominators if they're higher numbers, can you be like 2?
Yeah, sometimes. Like if we were doing something like if I had 1/8 plus, or, plus like 2/16, I could see that 2/16 is the same as 1/8. And so my answer is 2/8 or 1/4. Right? For this one, I just reduced it down to get a common denominator. That's definitely something you can do. All right? Now, let's imagine something else. Let's imagine instead I had 2/3 divided by 7/4. Now, we don't use this symbol very much in algebra. The way that you would actually see this in practice is you would see 2/3 divided by 7/4. Do you see how this is the same thing as this? These are the exact same thing. It's communicating the exact same information. We're just more likely in algebra to see it like this. Now, when we do this, whenever we're dividing by a fraction, what makes the most sense for us to do is to actually multiply by the reciprocal, so that all of this becomes instead 2/3 times 4 over 7. The reciprocal. If I have the numerator over the denominator, the reciprocal means I flip it. The denominator becomes the numerator becomes the denominator. So that's what I did. 7/4, all I did was flip it, and so I get 4 over 7. Now I just multiply across, I get 8/21, and that's my answer. All right? Now this works no matter what. If I had 2/3, but I was dividing it by, Oksana, what month were you born in? February, by 2. So if I were dividing it by 2, right? If I were dividing this by 2, you're thinking, well, 2 is not a fraction, but we can still multiply by the reciprocal, right? In this case, we always imagine it's 2 over 1. So I flip it. So 2/3 is actually the same as 2/3 divided by 2 is the same as 2/3 times a half. You guys see that? So that becomes 2 over 6, which reduces down to 1/3. Or if you see it ahead of time, you see that these 2's will reduce down 1 over 3. Yeah? Because the 2/3 isn't the 2/3 is what's being divided, but it's not what we're dividing by. Whatever number is our numerator, we don't flip. We only flip our denominator. We only flip by the thing that we're dividing by. Okay? So like if I had 5/2 divided by 2/12, this is the thing that we're going to flip. It becomes 5/2 times 12/2. Okay? It's always the thing that we're dividing by that flips. Or likewise, if I had 5/2 divided by 3, This is the thing that we're going to flip. So that becomes 5/2 times 1/3. Okay? It's always the thing that's in our denominator or the thing that we're dividing by that we're flipping. All right? You guys remember this stuff?
Yes.
You're just kind of like haven't used it in a while?
Yeah.
Like this is fraction rules. Fraction rules are absolutely integral to us being able to do our homework. It's integral to us being able to do algebra. Remember, we're using fractions all the time when we're talking about slope. We're dividing equations constantly, and whenever we divide, we're creating little fractions all over the place. We have to understand how these rules work and how they interact with each other to be successful at this level. All right, I'll stop this video and we'll continue on with what we're doing in our homework, and I'll post this later tonight.